Hey guys, in this video we're going to be solving a triple integral. So specifically we're going to be solving this volume integral. So the integral from, well, the radius from 0 to some arbitrary value that we're just going to call a in this case. The integral from theta equals 0 to 2 pi, and the integral from phi equals 0 up to pi of this particular function here. R squared sine of phi actually no, it's going to be d phi d theta dr. So you might imagine this is a triple integral that you might see in calculus 3 or any course like that. But the reason we're going to do this is because this is just pretty much a general example of how to evaluate a triple integral. So the way you take a triple integral is you treat the other variables as constants. So we just start from the inner integral and we'll go to the outside. So we'll start with this one first. So we're going to integrate this with respect to phi. So the integral from phi equals 0 up until pi of r squared sine of phi. Now we don't have to do by parts because r isn't dependent on phi. The only thing dependent on phi is sine. So the integral of sine is going to be negative cos. So this is going to turn into negative r squared cos of phi, big square brackets, phi equals 0, and pi. Okay. Now when you put this in here, you're going to have two values. Now, because as soon as you put in phi equals 0, that's not going to be 0 because cos of 0 is 1. So this is going to be brackets negative r square cos of phi, pi, sorry. So we're substituting the pi in first. So pi minus negative r squared cos of 0. Okay. Cos of pi is negative 1, so this is going to be r squared. This here is going to turn to a positive, so plus r squared, and this is just going to be 1. Okay, so all we have is 2r squared. That's all we have left. So our triple integral now turns into a double integral. So now I'm just going to literally just copy this and put it down here real quick. So now that middle bit is gone, it now turns into pretty much a double integral with just r squared. Now, we've got to integrate with respect to theta. So, theta, it's not present in here at all. So all we're going to do is do this little integral here. So the integral of from 0 to 2 pi of r squared d theta is just going to be, well, r squared just theta, because r squared is going to be treated as a constant, and then you have 0 and 2 pi here. Okay. Substituting in 2 pi, you're going to get 2 r squared pi. Actually, that's going to be, that's 2 pi, so you're going to have 4 pi r squared. 4 pi r squared, and then minus the 0, and that's it. So now all we're left with is the integral from 0 to a for r of 4 r squared pi dr. Now, you're probably thinking, why is this a volume integral? Well, this integral actually evaluates the volume of a sphere, because if you integrate this, you're going to get 4 pi cubed over 3 pi, and you have r equals 0 and a, where a can represent the volume of a sphere. So the formula is 4a cubed pi on 3. So that's a triple integral evaluated, and it gives a proof for the volume of a sphere. Hope you enjoyed this quick little video.